In this particular video, I'm going to show you a little bit different way to do multiplying and dividing fractions compared to what your book shows you. Now what our book wants us to do is they want us to go through and do prime factorizations of all the numbers and cancel out what's top or common top to bottom. I'm going to kind of use that idea, except I'm not going to go through and do a prime factorization of everything. I'm going to talk about factors. So I'm going to do it very similar to what I've done in previous videos. So here's what I know based upon what you've been taught in your book. I know that I'm allowed to reduce anything as long as it is top to bottom. We can never, ever, ever go straight across. So when I look at this particular example where I've got 7/8 times 2/3, I want to look for things that are divisible or that go into both the top and the bottom. So if you see 7 and 8, nothing goes into both of them besides 1 doesn't do us any good. Same way with 2 and 3. Nothing goes into those other than 1, so we're stuck with that. 7 and 3, now even though it's diagonal, it's still top to bottom. That doesn't really work out for us either, but that 2 and that 8, I know that 2 and 8 are both divisible by 2. So I'm going to go ahead and do that. So 2 divided by 2 is a 1. 8 divided by 2 is a 4. So what my hope is now is that I have reduced this as low as it's going to go. And I should be able now to multiply straight across, and I should end up with something that is completely reduced. So 7 times 1, of course, is 7. And 4 times 3 is 12. And, of course, we know that's reduced because the only thing that goes into both of them are 1. Let's try another example, and let's put some more numbers in here. So what if we were given the example 27 over 32 times 10 over 13 times 16 over 30. And guys, remember, to be able to do this, you have to be very, very good at your multiplication tables. You got to know what your factors are. And you also have to understand it doesn't matter where it's at, on top or bottom. It just has to be top to bottom when you reduce. So if I look at this particular one, let's just see here. Oh, I see this 16 and the 32. So let's start there. 16 and 32 are both divisible by 16. So I'm going to go ahead and mark those out. So 16 divided by 16 is 1. 32 divided by 16 is a 2. So we've got those completely reduced. Now let's look around and see what else we can reduce. 13 is not going to reduce with anything on top because, of course, it is prime. But that 27, if I look at the 27 compared to the 30, 27 and 30 are both divisible by 3. So let's go ahead and reduce the 27 and the 30. Now I'm going to use a different colored pen here. So 27 divided by 3 is going to give me a 9. And 30 divided by 3 is going to give me a 10. Oh, and I love the fact that that 10 come out of there. Because if you'll notice, I also have a 10 right there in the middle on top. So I can actually go ahead and reduce those two 10s. So this 10 right here is going to go to a 1. And this 10 right here is also going to go to a 1. And guys, please make sure when you're canceling stuff out like this, you are left with 1s. You don't get 0. They don't just magically go away. You're left with 1s. So if I go through now and multiply what we've got, I've got 9 times 1 times 1, which is going to give me a 9. And I've also got 2 times 13 times 1. So 2 times 13 is 26. 26 times 1 is still 26. And guys, that is completely reduced. And what this does is this saves you all that time you have to put into doing prime factorizations. Okay, let's look at one division problem. Now guys, division really is the same thing as multiplication. So let's say we're given the problem 14 over 52 divided by 1/13. Here's what you need to know about division though. We are never, ever, ever going to do division. Instead, a great way to memorize this is this. We are going to keep, we are going to change, and we are going to flip. So what does this mean? When you see a division problem, you keep the first fraction the same. So it's going to be 14 out of 52. You are going to change division to be multiplication. And instead of having that 1/13, we're actually going to multiply by 13 over 1. So we keep, we change, and we flip. Guys, this is the same thing as saying we're going to multiply by the reciprocal. It's just a little bit easier to keep track of. And now, since it's a multiplication problem, I can do the very same thing I was doing in the previous two examples. So let's look and see if anything goes into anything else. So 13 and 52, I know 13 and 52 are both divisible by 13. So 13 divided by 13 is a 1. 52 divided by 13 is a 4. Now, we do have these two 1s on the end here, but if we cancel them out, we're left with 1, so I'm not going to mess with those just yet. We also see that we've got 14 and 4. Both of those are even numbers, so they have to be divisible by at least a 2. So 14 divided by 2 is going to be a 7. And I'm going to take 2 out of this 4 here, so 4 divided by 2 is a 2. And I think that's everything we can do, so let's multiply straight across. So 7 times 1 is a 7, and 2 times 1, of course, is a 2. Now, I'm going to leave this as an improper fraction. Guys, if you wanted to and the directions requested it, we could change that to be a mixed number. And if we change that to be a mixed number, we'd just say, okay, well, how many times does 2 go into 7? And that would be 3 times evenly with 1 left over. So if we wanted a mixed number, that's how we'd write it.